Okay, so we now go on to order selection without repetition. And so obviously in this case, does order matter? Yes. And is repetition allowed? Obviously this is no. I just can't bother to write out the whole thing again. And so I've got here the definition of order selection with repetition of the sample space from before. But the order selection without repetition definition is very, very similar. So I'll just quickly state the minor changes it is that have actually occurred, rather than writing out the whole thing again. So obviously we've still got an x as a set, and we've still got the modulus of x equal to n. And if we make an ordered selection of r elements of x without repetition this time, then the sample space is a set of all r element sequences, also called r truples, of distinct elements of x. Because obviously if we're working with repetition, or without repetition I should say, then you can never have a sequence with two elements being equal, because once you've used that element you can't use it again. And so the sample space is going to be relatively similar. You're still going to have your set, and you're going to have x1, x2, xr, such that xi is an element of x with xi not equal to xj, I believe it said, for all I not equal to j, right? So you've still got the same thing. So you've got xi not equal to xj for all I not equal to j. That's obvious because, like I said, you can't have any sequence. Every element it can't be equal to each other. So for example, in the case of the balls out of a bag from before, we couldn't have ww because xi can't equal xj, and so we can't have, once we've taken w out of the bag, it doesn't go back in. And similarly for the Football Manager example, if this was without repetition, we couldn't have keeper free, because obviously once keeper free's played the first half, he wouldn't be able to play the second half. Okay, but what I wanted to focus on is what is the modulus of the sample space, because obviously you know that the modulus of the sample space is n factorial over n minus r factorial. But how did we actually get here? How is this, does it actually make sense? So let's just try to make sense of it. If you remember before, I had a drinks scenario where I said I had 6 drinks, and I briefly mentioned about how I pick 4 of them. Right, so let's say let's say it was ordered without repetition this time. So every time I picked a drink, it wouldn't get placed back on the shelf by the shopkeeper. So if I'm picking 4 drinks, obviously I've got 6 for the first scenario, for the first drink I pick, 6 choices, 5 choices for the second, 4 choices for the third, and 3 choices for the fourth. Okay, and in this case, the modulus of the sample space would be 6 times 5 times 4 times 3, which is 360, right? And obviously you can just do this formula as well. But why does this formula work? Well, let's make the general case, right? So let's say there's n drinks to pick from, and I pick R. So what's that modulus of the sample space? What's that going to be? Well, that's going to be, I'm going to have n choices for the first one. I'm going to have n minus 1 for the second. And obviously you're all aware of this, n minus 2, so on and so forth, until I pick the R, the ARF drink, ARF drink. So let me just rewrite this because I just want to briefly show something. So n, I can write that as n minus 1 minus 1, because obviously this is just 1 minus 1 is 0, and so n is, and then n minus 0 is n. So I can write it like that. You'll see why in a moment. Just bear with me here. And so I'm going to write them all like that. So I'm going to have n minus 2 minus 1. So this is the second drink I pick, and obviously this is the same as this, and so on and so forth. Okay, but for the ARF drink, what's going to happen? Well, this is the first drink I pick, the second drink, that's supposed to be a 2. Hopefully that's clear. Let me just zoom in actually to make sure. That's the second drink. This is the third drink I pick, right? And obviously all these correspond to these 3 here. Well, once I pick the ARF drink, what's that going to be? That's going to be n minus r minus 1, right? And so if you expand that bracket, what's that going to be? That's going to be n minus r plus 1. So this last one here is n minus r plus 1. Hopefully that's clear of how that's actually how we actually get n minus r plus 1. It's just something that when I initially saw it, I was confused. So maybe others were confused on it as well. If not, then that's fine. But now let's get to actually proving the n factorial. So what do we have? So we have that the sample space, right? The sample space, I'm just going to rewrite it here just for more space. It's n times n minus 1, and then the n minus 2, and then all the way till n minus r plus 1. Okay? And that was shown just now. So what is this? So basically, as mathematicians, right, you always want to simplify something. That's all. That's the whole point, right? We take a problem and we manipulate it in such a way that it now becomes a mathematical problem which can be solved by some property or some technique that we know. And in this case, that thing that we know is factorial. That's what we know, and we know that we can see that this is part of n factorial, part of it. It isn't the whole thing. Like, for example, if I had n equals 80 and r was 60, this last one would be 21. So I wouldn't have, this isn't n factorial, but it is part of n factorial, right? Because it begins at n and then you times by every integer less than it. So what would I have to do to get n factorial? What would I have to do? Because obviously that's what the formula says, right? It says it's got n factorial, right? What would I have to do? I'd have to continue. So I'd have to do times n minus r, and then times n minus r minus 1, and keep going until I got to 3 times 2 times 1, right? In order to get there. Okay, but don't forget, right, this right here, just put this, what I put in square brackets, this is the sample space, right? So so by me timesing by n minus r minus 1 and all this, this is going to affect the sample space. So I still want to have my sample space, right? So obviously what I'm going to do is I'm going to divide by the same thing. So I'm going to divide by n minus r minus 1 all the way down to 3 times 2 times 1. Because obviously I don't want my sample space affected. So this is the same as it's like doing 7 times 5 over 5. It's still going to be 7, right? But now what do I know? Well, this whole thing, this whole numerator here going all the way up here, what's this? This is n factorial. And what's this at the bottom here? n minus r minus 1 going down all the way to 1. Well, that's n minus r factorial. And so you can actually work out the sample space with n factorial divided by n minus r factorial. And hopefully that was clear. If it wasn't clear, obviously do say, and do mention, so I'll make another video on it. Hopefully that was clear. But that's how we actually derive n factorial over n minus r factorial. I know that's actually the main problem of order selection repetition, because obviously in the exam you're just going to use this formula, and that's fine. But just in case questions come up or you're just trying to understand where that's actually come from, that's what's actually happened. And I've gone a bit over time, I've taken a bit longer than I originally planned to. So next video I'll have an example of ordered selection without repetition, but hopefully this was clear about how the actual formula comes across, because that's the main aim, to actually understand what we're doing, not just doing it for the sake of doing it. So next video I will go on to an example of ordered selection without repetition.